Welcome back, students. In this video we'll be doing question number 14 of exercise 7.7. So this is the question which is given, okay? You're asked to integrate the function. Alright, so it follows the same procedure as question number 12 and 13. So what you're supposed to do is you're supposed to take x plus square, equate it to this and differentiate whatever is under the square root, which is 3 minus 4x minus the quadratic equation which is inside the square root plus b. Okay, so after this we get this is x plus 3 which is equal to a, and the differentiation of 3 is going to be 0, so you can write it as 0 or leave it as it is. Differentiation of 4x is 4, and the differentiation of x squared is 2x, alright, plus the b. So x plus 3, you multiply them, a into 0 is going to be 0, so I just leave it as it is. A into minus 4 is going to be minus 4a, and minus 2x into a is going to be 2ax, okay, plus the b. Now we have to equate the coefficients of x and the constant term on both sides. Okay, so you'll get this. The coefficient of x on the left hand side is 1 and on the right hand side is minus 2a. The constant term on the left is 3, the constant term on the right is minus 4a plus b. So this way your a will be minus half and your b is going to be 3 plus 4a equal to b, and you know that your a is nothing but 4 into minus half, so you can take this up, so you'll be left with 3 minus 2 equal to b. That means your b is equivalent to 1. So you already have the values of a and your values of b. You can always write this as x plus 3 equal to a into minus 4 minus 2x plus b, okay? So you know the value of b, you know the value of a, so let's substitute that. So x plus 3 is going to be, your a is half, and under the bracket it's minus 4 minus 2x plus 1, because b you got it as 1, right? So you just substitute this. Therefore integration of this, that is integration of x plus 3 of square root over 3 minus 4x minus x squared dx can be rewritten as integration of x plus 3 is half of minus 4 minus 2x, okay, plus 1. Remember, minus half is only for this equation, it's not for this entire thing, okay, into 3 minus 4x minus x squared into dx. So you just multiply them. You'll be getting this as, you can put this under bracket as well, okay. So you multiply minus half minus 4 minus 2x with this, so you'll be getting this as minus half of minus 4 minus 2x, the square root of 3 minus 4x minus x squared dx, okay, plus integration of 3 minus 4x minus x squared of dx. Okay, I hope you're clear with this, okay. Take out this constant term outside and rewrite this as 4 minus 2x. This is just an unnecessary step, okay. You can always proceed without this step. Dx plus integration of 3 minus 4x minus x squared of dx. Finally, you can write this as minus half of I1, okay, plus I2. Okay, so you know what I1 represents this and I2 represented by this, alright. So let's go with I1 first, okay. So for I1 alone, integration is actually minus 4 minus 2x, a square root of 3 minus 4x minus x squared. This is fairly an easy one, so we can do this by substitution method. So you take your t as 3 minus 4x minus x squared. Okay, so differentiate this. So when you differentiate this, the differentiation of 4x is going to be 4 and the differentiation of x squared is going to be minus 2x. Clear? So you already have what you need. What is 3 minus 4x minus x squared? That is the same thing as t. And what is minus 4 minus 2x? Minus 4 minus 2x into dx is going to be dt. So you can always rearrange them. I keep on telling this is the same thing as, okay, it's a multiplication. It's multiplication in between minus 4 minus 2x and 3 minus 4. So it's the same thing as 2 into x or You can write it as 2 into 3 or 3 into 2 or x into 2 or 2 into x, okay? Does not really make any difference, right? So just for the easier computation. So 3 minus 4x minus x squared is the same thing as t. Minus 4 minus 2x into dx is, you look at this, minus 4 minus 2x into dx is what? dt. So replace that, okay? So the integration of, now we are integrating it with respect to t, so integration of t square root is t to the power half, okay? So this becomes t to the power 3 by 2 and 3 by 2. Okay, if some of you are still not very familiar with integration, this is the formula, okay? That's how I get, okay? Because it's n plus 1, right? X to the power n, integration of this is always going to be x n plus 1 divided by n plus 1, okay? Clear? So in the case of this, our n is half, so I'm replacing this. So t to the power 3 by 2 and 3 by 2. So this becomes, replace this, 2 will go to the numerator, 3 will go to the denominator, and this is t to the power 3 by 2. After that, your t, substitute it back. What was your t? It is 3 minus 4x minus x squared of 3 by 2. So we already have our value of I1. Next, let's go for I2, okay? Now for I2, it's a question very familiar to question number 5 in the same exercise, okay? Exercise 7.7. It's very similar to question number 5. So this is 3 minus 4x minus x squared. So let's do one thing. Here, 3 minus 4x minus x squared. You look at this, just focus on these two alone. Do not focus on 3 right now, okay? Minus 4x minus x squared. So what you're supposed to do is you kind of need to add 4 and minus 4. Alright? There's a need for this because remember we are trying to get it in one of the forms, x squared minus a squared, x squared plus a squared, or a squared minus x squared. Clear? We're trying to get in one of this form, okay? So even for this we're trying to get in that form. So when you really focus on minus 4x minus x squared, it kind of reminds you of an equation that is something like this, right? x plus 2 squared will give you x squared plus 2 into x plus 2 squared. So just ignoring this, but at least you have x squared plus 4x. Obviously there's a negative sign, but just do not get worried. But that's when the constant term in the quadratic equation, right? This is a quadratic equation, x squared, ax squared plus bx plus c. Your c here serves as 4. So when you really look into that, focus on that equation, the only time 4x will occur is when your constant term in the quadratic equation happens to be 4. So because of that, I'm just adding 4 and subtracting 4, alright? So you bring this 7, 3 plus 7, make it 7. So you'll be left with 4x minus x squared minus 4 dx, okay? And then take a negative term common. So when you take negative, you are left with 4x plus x squared plus 4 of dx. Now, this is, so 7, can I take it as root 7 the whole thing squared? Either ways, when you take root 7 the whole thing squared, it becomes 7 itself. So this is 4x plus x squared plus 4, which is the same formula as x plus 2, right? Because x plus 2 the whole thing squared is x squared plus 4x plus 4. So replace that, okay? Dx. Now see, whether it's x or x plus 2 does not really make a difference, okay? Because remember, anything that you apply for a given function, x integrated with x, which is x n plus 1 by n plus 1, you can always, okay, substitute that. Suppose your n happens to be greater than 2, right? In the sense it's 3 or maybe 5 also. You can always use the same formula, okay? You can always use, in the sense, you can always use it as 5 plus 1 divided by 5 plus 1 in the sense, okay? Because this is a linear equation, okay? We take up, ignoring the power, this x plus 1 in itself just becomes a linear equation, okay? So oftentimes you come across this. So whatever you have applied for x alone, whenever you are given a linear equation, just x plus 1 like that, you can always apply for the same. So this is in the form of a square minus, this is in the form of, okay, you can always write it is in the form, in bracket, in the form of a square minus x square, right? Okay, this is in this form. So let's use this formula, okay? That is, I'll rewrite this and write here as integration of, remember we're finding it for I2, this is root 7 the whole thing square minus x plus 2 the whole thing square. So when you use the form, you will end up getting this as a square minus x a square formula. Remember the three formulas, okay? Go back to my first video or just refer for Nbse, refer page number 329. All the formulas in bold you'll have to remember. So half into x, instead of x you cannot write x alone because x is written as x plus 2, so you have to write it as x plus 2. Integrate this with 7 the whole thing square minus x plus 2 the whole thing square plus your a square over here is 7 square by 2 sine inverse of x is x plus 2 divided by root 7 plus c2, okay? X plus 2 by 2, remove this, so 7 root 7 square becomes 7, open up the bracket, so this becomes x square plus 4x plus root 7 square becomes 7 by 2 sine inverse of x plus 2 by root 7 plus c2, okay? So x plus 2 by 2. Now when you solve this, you'll be getting this as 7 minus, okay, just remove the bracket. If you can always do without the bracket, well and good. Okay, if you're kind of well versed with integration, you can skip some steps, but if you're not so well versed, I would suggest you to try to do a step-by-step method so that you don't make mistakes. So 7 minus 4 becomes 3, so you're left with x squared minus 4x, which is the same thing as per the question, right? The quadratic equation that occurs inside the square root. Okay, so this is what you are getting for I2. So finally, therefore, your I can be written as, what is your I? Your I, we got it as minus half of, okay, so your I is equal to minus half of I1 plus I2, and your I1 is 2 by 3, right? Let's omit the bracket, okay, 2 by 3, and I1 is 3 minus x plus 2 by 2, 3 minus x squared minus 4x plus sine inverse of 7, no, sorry, it is 7 by 2 first. 7 by 2 sine inverse of x plus 2 by root 7 plus c, okay? And then you can finally cancel out 2 and 2, and you'll be left with minus 1 by 3, 3 minus x squared minus 4x of 3 by 2 plus x plus 2 by 2 root over 3 minus x squared minus 4x plus 7 by 2 sine inverse of x plus 2 by root 7 plus c. Okay, so this is the answer. Alright, so we shall end the video here, okay?